is a bearings question. So the ship leaves port P and sails on a bearing of 65 degrees, which means that this angle in here is 65 degrees. And we know that this is 100. It sails from Q 80 kilometers on a bearing of 160 degrees. So this angle here then is 160 degrees. So what I'm going to do then is to just drop a north line down, the north line down like so. Here we have a Z angle. So this is 65 degrees. And we know then that this is 20 degrees because 20 plus 160 gives us 180. So the angle inside the triangle, this angle here, is 65 plus 20 is 85 degrees. Now we've got the angle between two sides, that's the cosine rule. So a squared equals b squared plus c squared minus 2bc cos A, and that's PR squared equals 100 squared plus 80 squared, 2 times 100 times 80 times the cos of 85 degrees. So that's 1640 minus 16 cos of 85 degrees, and that gives, so we have PR equaling 122.5 kilometers. What I'm going to do next is to work out this angle here. We've now got a side angle pairing, so I can use the sine rule. A over sine A equals B over sine B. So 80 over sine X equals 122.5 over sine 85. Now cross multiply, and 122.5 sine X equals 80 times sine 85. Sine X then is 80 sine 85 all over 122.5, and X equals sine to the minus 1 of that. And it gives, and that equals 40.6 degrees. So this is 65 degrees. It's 40.6 degrees. This whole angle then is 105.6 degrees. Now, just add something onto the diagram, a line like so, continuing the dotted line. I'll do that in order to mark in this angle, which is 105.6 degrees. So if I'm standing at R, facing north, I turn through 105.6 degrees and 180 degrees. So the bearing that I'm looking for is 180 degrees plus 105.6 degrees, and that equals 285.6 degrees. Area is nice and simple. The area of the triangle is a half AB sine C. 1/2 of 10 times 9 times sine of 34 degrees. That gives me 25.2 centimeters squared. Area equals 1/2 of 55.8 times 10.6 times the sine of 140 degrees, and that equals 19.8 centimeters squared. Now, this is a useful variation on the area question. Remember the formula, area equals a half AB sine C. We know that the area is 31, and we have 1/2 of 8 times 12 sine, well in this case it will be sine B. We don't need to fuss too much about the letters. So 31, 1/2 of 8 is 4, 4 times 12 is 48. And then divide both sides by 48. Sine of B is 31 over 48. And B equals sine to the minus 1 of 31 over 48, which gives us 40.2 degrees. Part A, the maximum value is 7, the minimum value is -7, and the period is 360 degrees over 3, which is 120 degrees. Part B, the maximum is 4.5, the minimum is -4.5, and the period of the cosine function is normally 360 degrees. We're going to divide it by this 2 here. It's 180 degrees. Part C. The tan function has no maximum and it has no minimum. The period is normally 180 degrees, but it's divided by this 4, which gives us 45 degrees. The maximum is 100. The minimum is -100. And the period of sine is normally 360 degrees, but this one has 10 cycles. So it's 36 degrees. Maximum here is 3.2 plus 4. The minimum is -3.2 plus 4. And the period of the sine function is 360 degrees, but here we have 6 cycles. Part A, well, we have a maximum of 1, and the minimum is -1, and the period is 360 degrees divided by 2, which is 180 degrees. Now we only want to draw one cycle of the graph, so I'll mark 1 and -1 on the axis. I'll mark 180 degrees here, then I'll half and quarter rather the x-axis. The sine function starts at 0, goes up to its maximum at the first division, down to 0, down to its minimum, then back. What we have then is something that looks like that. So for part B, we have a maximum of 20, I have a minimum of minus 20, and the period is 360 divided by 3, it's 120 degrees. So I'll mark 20 here, minus 20 here. I want just the one cycle, so that's 120, 60, 30, 90 degrees. Cosine starts at its maximum, goes down to 0, down to its minimum, back to 0, and to its maximum. So we have something that looks like this. So part C. Now the maximum is 3, the minimum is minus 3, and the period is 360 degrees. But this negative 10 degrees means that it's been shifted to the right by 10 degrees. So we'll see what happens. I'll mark 3 and minus 3 on the axes. I want one period, or one cycle. I'm going to mark 360 here, and then quarter, first of all half, and then quarter the x-axis. And then what I'm going to do is to draw the graph of sine x as a dotted line. And I want to move each of these points, I want to move each of these points 10 degrees to the right. So approximately here, doesn't need to be exact. And we want to have a full line. Like so. Now, I really want to cut the graph off at this point. So what I'm going to do is to take this part here and add it in at the front. Okay. I think it's probably best if we put in some information. So what have we got? This point here is, that's 10 degrees, 0. This point is, it wasn't 90 degrees, it's now 100 degrees. And it's at 3. This point here is, it was at 180, it's now 190 degrees. 0. That was 270, so it's now 280 degrees minus 1. And that's us, I think. Part D then, the maximum value of this function is 5, take away 1. The minimum value of the function is minus 5, take away 1, which is minus 6. And the period of the function is 360 degrees divided by 2. That's 180 degrees. So the first thing I'm going to do, I'm going to mark 4. I'm also going to mark the minus 1 here, and then minus 6. I'll mark 180 degrees, and then half and quarter the x-axis, very approximately. Now, the cosine starts at its maximum value. Here it is here. At the first division on the x-axis, it goes down to the the middle point, which is -1, and then down to its minimum at 90, back up to the middle point of its motion at 135 degrees, and then back up to its maximum at 180.